Thanks for coming. I'm Boris Weissman. I'm a co-founder of Datrium. I have a little bit different background, just probably similar to many of you here. My background is in virtualization, about 20 years now. Here at VMware, for 11 years focusing on core, hypervisor, and fault tolerance. I'm an engineer. I write code every day. This is what I do for a living. So this is not something I do normally. So bear with me. OK, so Elastic Replication. So I was an architect on the project. And basically what it is a reinvention of replication for private clouds. And so replication is a fairly well-known mechanism used for a long time by traditional arrays as a data protection mechanism. And in a nutshell, it basically copies your data from one storage array to another storage array. And it's been used for a long time. It's especially effective when combined with snapshots. So snap and replicate, it's a fairly useful technique, especially for environments with limited bandwidth between sites. So that's the background. And what I have here on the slide is a bunch of features that you should expect to find in mature storage arrays. They should support various topologies, one-to-one, many-to-one, one-to-many, bidirectional. They generally have some support for shaping network traffic between replicating sites, end-to-end data reduction, including data reduction on the wire, monitoring, fault detection, all of those things. So we do have all these features, even in V1 version of our product. So, but the main contribution here is that instead of traditional arrays implementing all these features inside array controllers, our implementation applies to the entire private cloud. So each box that I have on this slide is a DVX system, which is a collection of compute nodes and data nodes, potentially dozens. And Elastic Replication is a software component, software layer, that automatically maps out the structure of these private clouds and makes compute and data nodes work together for the purposes of replication. So you don't need to individually manage hosts or controllers. You just apply policy at a high level, and then the hardware is managed at scale by Elastic Replication. But from the outside, you get exactly the same familiar features you would expect from a mature storage array. Just to pop up one level, any replication system, to be effective, essentially has to solve three problems. So first of all, it has to replicate data, and it has to do it efficiently. And by that, I mean it should only replicate data that has changed. It should not be replicating data that hasn't changed or wasn't requested for replication just because it's convenient to do so. So that's sort of logical. That's number one. Number two, data that goes on the wire better be, we better apply data reduction policy for everything on the wire, right? So we should use network efficiently. And number three, avoiding centralized bottlenecks is a sort of a requirement here to scale the system. So those are the three things that any replication system should address. And so in our implementation, going back, so number one, it's replicating only what's changed. So because our Elastic Replication is tightly integrated with the file system, and our file system is all about virtual machines. So we know what a virtual machine is, we know how to manage them, we know how to attach policies to them, we know how to replicate them. So while traditional arrays are very good at replicating LANs, LANs are generally much bigger units that potentially could have hundreds to thousands of virtual machines. And because that's the only language understood by arrays, the only currency, well, that's what they replicate to. So you might want to attach different replication policies to different virtual machines, but you don't get to do that with arrays because you can only attach policies to LANs. So what gets replicated is generally LANs. Not so with Datrium Elastic Replication. So protection groups, as Asala was outlining, so all of this is integrated with replication. You can replicate virtual machines, or you can replicate protection groups. It's all integrated with snapshots. So what gets replicated are consistent images, consistent snaps. And only what's changed is replicated. So that's requirement number one. Number two, data reduction on the wire. Again, we benefit here from a tight integration with the underlying file system. So because Datrium automatically compresses and deduplicates everything, both on flash and on disk, because our replication, and we're the same vendor, and we know the internal data representation. When we are replicated, we don't need to uncompress anything, we don't need to undeduplicate or rehydrate anything, we just know. So we start on the source with compressed, deduplicated data locally on the source cluster. We take that, and the only thing we do, we also deduplicate it against the destination before even transferring the data. So what you see on the wire is at the absolute minimum. You know, it's data compressed, it's deduplicated locally, and deduplicated against the destination. So that's requirement number two. And number three is avoiding bottlenecks. And from the picture here, it's sort of obvious what's going on. So in traditional storage controllers, storage arrays, it is generally the controllers that manage data flow for replication. And they're exactly the same controllers that also perform inline I/O at the same time. So when replication kicks in, well, that has an impact on inline I/O. That's not so for Datrium, where under normal operating conditions, our data nodes, they don't even know replication is going on. They're not a part. They certainly do not transfer any data. Instead, replication as managed by the software actually happens, and data transfer is managed by compute nodes, not by data nodes, by compute nodes. And what it means is that recently written data, this is the data that we want to replicate, well, it happens to be on local flash of the compute node, so you have just written it. So we take this data, read it from local flash, and we replicate it concurrently to the compute nodes of the destination cluster. And what it means also is that replication can go on concurrently by multiple streams originated from the source nodes, compute nodes, to destination compute nodes. So concurrency is there, bandwidth is there. In fact, bandwidth is so high that we had to actually add network traffic shaping to actually throttle the bandwidth, because some initial feedback was that people didn't want to pay too much for bandwidth use, so you can control that now as well. And again, so despite all of these moving parts, so all of this orchestration is performed at the level of the entire cluster by Datrium Elastic Replication. And just before you guys ask a question, so but what happens to my VMs? You put even more functionality into compute nodes, don't they get cycles to run VMs? Fair comment. I just want to point out that just like with compression and with encryption and replication and everything, erasure coding, we are subject to exactly the same 20% reservation in fast mode. And what that means is that the cap is 20%. We can never use more than 20%. If we don't need 20%, VMs will use more. So VMs will entitled to 80%, perhaps more if we don't use it. So all of these features we described, they're under the same umbrella, capped at 20% for fast mode.
Can I? So you guys, so the data nodes you're talking about, and you've been talking about them the whole time.
Yeah.
You said that I can do it with just one node, right? Yeah. But if I want to expand,
yes,
I can expand. So when you get into fault domains and things like that,
you will soon.
Oh, okay, so right now it's only one data node.
Yeah.
Can I go ahead and ask the fair question? I mean, I think it's a fair question. Is when I get into fault domains, right?
I like how you look at me like, yeah, go ahead.
No, I should have looked at Jason, but
Your blessing.
You did look at Jason.
Exactly. Yeah, well, I just picked one Jason. But when I get into fault domains, right? I mean, typically when I'm setting up a fault domain, I have different namespaces and different IP spaces across racks and things like that. How are you guys going to solve? You're going to, from a perspective of a VIP or of your data nodes. How are you going to solve that? Is that open for discussion now, or?
Well, with the single node,
I mean, that's a non-issue.
Non-issue.
But when I get into multiple racks and I have different IP spaces across racks and I put in these data nodes, if I need true replication and things like that, are you going to contain it within a rack?
Yeah, so, well, it doesn't necessarily have to be bound physically to a rack.
Right.
right? But it is assumed that all of the hosts and all of the compute and data nodes are on the same data network,
Okay. Yeah.
right?
Yeah.
That's the elemental building unit, right? The same assumption is not the case when going DVX to DVX.
Right.
So your larger cloud infrastructure is built of the DVX units.
Right.
Within the DVX, we assume a data network, then all of the hosts and data nodes are on that same data network.
So you
But that can
assume-
be different from a management network, for example.
Yeah, because yeah.
That is, of course, different. Like, just to be clear, here, these are different DVX instances. They use completely different networks. In fact, they could run different software versions, right? And this could be WAN, right? So that's...
Yeah, I mean, because typically you'll have your application come in one network and have your data write to the other network and that. I'm just thinking from a perspective of when I have multiple racks, I might not have the same flat network between racks, which my fault domain would decide that for me. So I need a way to be able to communicate from data node to data node on different IP spaces, which also affects how my communication occurs between my application or from the appliances or whatever back to the data nodes.
So good point. Once we have this functionality, we'll
No,
come back
that's
to it.
fair.
But
No.
you do have, in this product, it's sort of true even here, because, so forget about data nodes. Here, these things could have like 4 or 8 different NICs
Right.
outgoing. So we have support for choosing which port group you use
Right.
for replication, because you could have multiple networks going out, and we support one-to-many replications, and you can, it's kind of a similar problem. You may want to go out on this network for this use case and that. So for that, we do have support for choosing specific outgoing networks.
And because you are saying it's NFS-like, right? Because I mean, that's reality. That's where the trickiness comes. I guess NFS 4 solves that problem, maybe.
Yeah,
But you
not really
still,
can't do that yet.
yeah, you still can't do it. So.
Yeah. And I'm sorry, I must have missed this.
Yep.
Replication compute to compute, right?
Yeah.
How do you handle write consistency on a cluster file system or something like, or clustered systems or something like
So
that?
be assured it's fully consistent.
You say that, but I want to know how you do that.
So,
Same button.
well, this is why you have people with 20 years of experience building that. So
I have 20 years of experience figuring out troubleshooting that.
fair enough. So forget, you're worried about snapshots being consistent, right?
Well,
Once it's not-
The short answer is we do snap and replicate.
Right.
These are not
Live
they're
replication.
These are not
not
continuous
they're not
data protection.
synchronously replicated. So the snapshots are consistently created within one DVX
Yes.
and replicated as a set of snapshots. So what you end up with is a consistent snap on the replica, but we are not saying that it is synchronously replicated.
So if the data node does the snapshot, correct?
Well, no, the snaps are done. The compute nodes are the ones
That
running
initiate.
all of this, and so they draw the line. Everybody says, "Okay, ready, draw the line," and
But
so
since-
that snap is consistent
Okay.
even across hosts. Yes.
So, but no compute node owns the full data set of a volume,
That's correct.
and we're doing
That is
compute to compute replication.
That is correct.
So
You
how
have
much?
it's a valid question. I understand your question.
So
It's absolutely correct.
are the compute nodes pulling data off the data node to then ship over the wire that then gets put back
Only
on the data?
logically. Physically, it doesn't happen. So to ensure consistency, it's absolutely correct question. So because there's a lot of data cached over here, how do you know you're replicating, wallet cache?
Right.
So you can think of it as logically all the data backend is in fact here, right? There's a copy of it over there. So compute nodes know which data is in fact consistent, right? During normal operation, it's almost always the case. So while we don't move data around, we do in fact maintain consistency maps on the compute nodes. So if they know that they're not caching something, this is why I said under normal conditions, data nodes are not involved. They are in fact involved if, for example, you just don't have enough flash, so you just don't have enough data. So that means you have to pull it from somewhere else. So under those conditions, you do in fact reach into data nodes, and when necessary, right? And this is how you achieve consistency as well.
So the compute would go into the data node, pull that data out to replicate?
Only under
Yeah.
extreme conditions,
Yeah.
but yes, it is
Okay.
in fact possible.
Okay.
Yes.
Thank you.
What's
Yes.
the timing on that?
So the timing, we don't really have like RPO. Our replication itself does not have any RPO requirements. It's whatever snapshot schedule supports, we replicate. It's generally a function of your churn rate and your pipe, network pipe. So we could be as fast as, depending on the ratios. Whatever snaps allow, we can replicate. It's only
Which is up to every 30 minutes.
Okay.
right. So it's tied to snapshot schedule. Replication itself has no requirements. Right. Okay. So so this is all fine, but what does it do for me? So we talked a little bit about how we have snaps and how you can use them for local backups, and there was a question, but it's local, so that's not good enough. So what can you do with replication? Well, you replicate it to a remote site, and suddenly you have this DR capability where there is a little bit of support, of workflow support for promotion of snapshot and making them live. And as Suzala pointed out, we are working very hard on actually automating network configuration post that. You can also think of cloning. Once the snaps are replicated to a remote snap store, they behave very similarly to locally created snaps. So everything you can do with the local snapshots on the destination site, you can do with replicated snapshots. You can clone them. You can sort of make real VMs out of them. You can think of maybe running analytics on these snaps to offload the primary node. And of course, what comes to mind, you can also replicate to potentially not a physical DVX, but maybe a virtual DVX running somewhere in the public cloud, which brings us to this slide. So we're also announcing that exact capability. So we are currently working on porting our software to a public cloud, with the first product available in Q1 2018. So it's a full file system port, which will expose a virtual replication target. So all the benefits of elastic replications we've discussed will apply directly to data replicated to Amazon. So you could use S3 on Amazon for extended storage of snapshots. And what I mean is that it's the same replication. It's incremental. It's native format, compression, deduplication, all of those things would just work. And we'll also add some search capabilities.
So do you run an appliance up in
Yeah,
okay.
yeah. So it'll run a virtual appliance.
Like an
the
EC2
entire
instance,
file.
and then, so is the data stored on S3 or?
S3.
Okay.
Yeah. Right. So, but as far as managing it, it'll be the same thing because it's just an appliance, right?
Yeah.
For like the multi-site and multi-fault domains, is it always one-to-one, or can it
No.
be
No,
as many
so
as I want?
you could support actually, and we call it end-to-end, but we support one-to-many, many-to-one, bidirectional. Moreover, it's not physical. The way you set it up is per logical protection group. So you can have some protection groups replicate in one-to-many, others replicate in many-to-one. It's all sort of between. So you end up with a mesh, and it's a graph, right? So you can tie these things together in which way you like.
So
So we'll have a demo. I think Mike will show the UI.
is AWS the only one on the roadmap, or are there?
Initially, it's not the only one, but this is the first one that we're committed to with a tight schedule. It's definitely not the only one. Any other questions? Okay, so now Mike will cover some of it in a demo.
Ooh, I do have one actually. If you
All right.
Going back.
Yeah.
I guess what I want to understand is when you're doing things to the cloud, are you
Yeah.
doing that through an S3 compliant protocol? Are you putting a virtual node in
No.
EC2 instance?
Right, so there will be an EC2 instance. The protocol between on-prem DVX, hardware DVX, and virtual DVX is exactly the same as between two hardware
Right.
DVXs. So you manage it the same way. Once it's there, so the reason we want to have an EC2 instance is because we want data. S3 is not as cheap as people think.
Right.
So because we want compression and dedupe up there, we kind of have to massage the data. We can't just, do it, we could rehydrate snaps, and like some of backup appliances do, but you end up paying 5 times more. So basically, you can think of it as essentially the same hardware appliance, only as a virtual appliance with the same benefits. Yeah. Okay. Okay, now the demo. Thank you.